Welcome to the fourth edition of the Prisma Meetup. I'm sorry, there's a small technical challenge here. We'll fix that in a moment. So, welcome to the Prisma Meetup. I'm your host, Daniel, and in case you're not familiar with this meetup, in this meetup we connect engineers from all around the globe to learn about database best practices and the growing Prisma ecosystem. And today we have three speakers. We have Nick van Wiggeren, who's joining us from PlanetScale, who's going to be talking about what's new in PlanetScale. That'll be followed by a talk by Ryan Dsouza from the Prisma team. He'll be talking about deploying Prisma on Lambda using the CDK. And finally, we'll have Harsh Singh speak to us about database design. So I also want to point out that today we have a raffle, and you can join the raffle by going to the following link. You can either scan the QR code or you can go to the link, and we are raffling the Designing Data-Intensive Applications book by Martin Kleppmann. In case you're not familiar with this book, this is really a book about the big ideas behind building reliable, scalable, and maintainable systems. As you can see, I have a lot of these sticky notes here. This is a reference book that I use a lot, and I think anyone working in modern sort of data-intensive, on modern data-intensive applications will find this immensely useful. So that is it for the raffle. We will announce the raffle towards the end of the meetup. And now I am very, very excited to introduce our first speaker. So our first speaker for today is Nick van Wiggeren, as I mentioned, who's the Director of Engineering at PlanetScale. And at PlanetScale, he runs teams responsible for the API, the front end, the database clients, and much more. And prior to working at PlanetScale, he worked all over the GitHub product and in many other developer-facing products that you may and hopefully love. So now, without any further delay, I'm excited to bring to the stage Nick van Wiggeren. How's it going, Nick?
I'm good. How are you?
Very well. I think the last time we spoke was Prisma Day back in the end of June. And since then, I've been following the PlanetScale progress. You have a beautiful change log. So first of all, kudos on that. It's really nice to follow the changes there. But besides that, you've been releasing a lot of new features recently, and this is, I believe, what you will be speaking about today.
Yeah, when I talked at Prisma Day, there was a lot of excitement, but we were still missing some key product functionality, I think, to make Prisma and other tools as useful as possible. So we've had a couple of months to make the experience better, and I'm very happy to be able to talk about what we've built and show off some of those features that make PlanetScale such a great product.
Great. Well, let's get right into it. Do you want to share your screen?
Yep, let's do that right now. Let's go there, and that is shared. Can hop right into Keynote really fast. You let me know when it looks good.
Okay, we're good to go. I'll bring you on.
Awesome. Well, thanks everyone. So I'm going to go over to Keynote here so that you don't just see the infinite recursion that is the Chrome window. And I'll go ahead and reintroduce myself. My name is Nick, and I am here to talk about PlanetScale and Prisma Part 2. So I was lucky enough to be able to have a talk at Prisma Day a couple of months ago, where I gave a demo about some of the fantastic PlanetScale features, things like database branching, and talk a little bit about what and why we built PlanetScale. There were also a number of parts of the product that were a little rough around the edges, especially for folks using Prisma. So we knew we had to make it better. We went back to the drawing board, and a couple of months later, I am incredibly excited to be able to share some of the additions that we've made to the product that make for what some people have called a superpower or an amazing set of database features. So before I launch into it, I want to make sure that I share some background for folks that may have not watched my Prisma Day talk or maybe may not be super familiar with PlanetScale. So to take it back from square one, PlanetScale is a MySQL compatible database as a service offering built on top of an open source project called Vitess. Vitess was built at YouTube many, many, many moons ago to provide for the hyperscale that a website like YouTube requires. You can think of all of the data that needs to be stored, counted, and spread across multiple machines. Single MySQL instances just don't cut it at that scale. And so Vitess was built to make it possible to run websites that get billions of views a day and have to keep track of what everybody is watching. So our goal is to be the best database as a service, the best, not just the best hosted MySQL, but the best database as a service. And we can offer that thanks to the incredible capability that Vitess provides, as well as some of our secret sauce that we've added on top from our experience building applications at scale at a bunch of different companies in our background. So as I mentioned, last time I showed off some of the product, but it was missing a few features. Connection strings were lacking, so it was very difficult to connect to the product. We didn't automatically track Prisma migrations and things like that. So the big thing that we've done since the last time I talked was connection strings. And that means that you can now go connect right to PlanetScale from the command line with the MySQL command line, or just by setting a database URL in Prisma. It's amazing. It works super well, and I will show it off in a moment. We also just today released a query analytics part of the product. And what that does is that actually does a live collation of all the queries that you're running against the database, sums and counts up how many rows have been affected, how many rows have been returned, and what the performance of those queries is. So it actually gives you kind of a real window into how your queries are performing on PlanetScale and what may be going well, what may not be going well. If you're curious about that, I'd highly recommend checking out the planetscale.com blog. We've got a ton of great information, including a story about how that feature helped us optimize our own application by adding some indexes and changing around some bad queries. And then the last feature, the last feature that I'll talk about here is Prisma migration metadata tracking. So much like Rails uses a schema migrations table and many other ORMs have this pattern, PlanetScale is now able to track what migrations have been run by Prisma and copy it over from branch to branch to make the branching workflow work a lot better. Would highly also recommend checking our documentation out on that at docs.planetscale.com. It makes using Prisma and it makes using our branching workflow that much more powerful. I'm personally tired of looking at my slides with a few words on them, and I would much rather show off the product in person. So I'm going to go over back to Chrome. Pardon this for a second. I'm going to go switch windows, and I'm going to show off the PlanetScale product. So this is the homepage. This has my list of databases and some stats about them. And I'm going to go into my Prisma Meetup 7, that's this Prisma Meetup database, and start to talk about some of the changes, and then actually use the database. So one of the big shifts, one of the big changes that we've made is that you can now go ahead and promote your main branch, which means when you create your first branch comes up as a development branch, which means you can change the schema on it directly. Previously, the first branch that you created was what we call a production branch, which means that the schema can only be changed by creating a second branch and basically opening a pull request. Now that we've done this, we can actually get started much faster. So I'm going to go ahead and click in on main, and I'm going to go ahead and create a password for this database. And this is that connection string feature that I was talking about. So instead of having to use pscale shell or pscale connect, create a proxy, and jump through a bunch of hoops.
Nick, would it be possible to zoom in a bit? Yep. Sorry to pause you.
Oh, you're good. No, you're good. I'm zoomed in a bit, but is that better?
I would go even one more.
One more. Okay. Perfect. How's that? Sweet. Hopefully everything else is zoomed in. If not, just go ahead and let me know. So over here, I've got my PlanetScale main branch of my Prisma Meetup database, and I've created a connection string for it. So you can see the password has got an automatically generated name, and I can actually go ahead and just go to the Prisma format, and you can see we've got the data source, username, password, and configuration all set up. So before we move forward, I'm going to go switch over to my IDE, where I will also zoom in a bit more. That's not zoomed in enough, just let me know. And I will go over the demo application that I made to show off PlanetScale, Prisma, and connection strings. So really, it's just about 30 lines of code that I wrote here. And all it does is on a loop, it inserts some random data, a UUID, as well as the host name of the machine that's inserting the data. And it just does this every 10 seconds, forever and ever and ever and ever, inserting into the database. If we go over to my schema, we can see I've just got one model here. That's a integer, a created at for when the data has been inserted, my host name, and my random data. And then I've got my PlanetScale database configured right here. So I'm going to go back to the PlanetScale website, and I'm just going to grab that database URL right there, and I'm going to go put it in my environment so that my local development now can talk to the database. I'm going to go back to my command line, and I'm just going to push that schema up right there.
Nick, could you make that also bigger?
Yep. Sorry about that.
Even a little bit more?
Woo.
All right, yeah.
It's about as big as it'll go. How's that? Awesome. So as you can see, hopefully now you can see, I've just done a Prisma DB push. So it connected to my PlanetScale database in the cloud, no proxies, no command line, and pushed my schema up. I'm going to go back over here and show off another feature that is coming soon. So I'm going to go over to the console, and this is now a web console connected to my production database where I can actually run some queries. So this is coming soon, and it's just another way to really quickly connect to the PlanetScale database, not have to jump through all those hoops. So we can see that the Prisma ORM went and created my data table, and I can see that there's nothing in it, 0 rows in data, because all I did was create it. So if I go back to over here, and I'll just run this really fast. So that's that loop, and we can see here, all I'm doing is inserting my random data and my host name, and I've got Prisma set to debug. And then if I go back and run this again, what we've just seen is my local laptop is already busy away at inserting random rows. So what we've demonstrated here is that with PlanetScale's connection strings and Prisma, we can very easily go from creating a database, just copying and pasting the database URL, setting up a schema, and pushing it to PlanetScale. But look, that's something that everyone can do. That's nothing super wild. Another benefit of PlanetScale, and something that I've talked about quite a bit at my Prisma Day conference and elsewhere, is because we're built on Vitess, we can handle an insane amount of queries, an awesome amount of connections to the database. Unlike other databases, we don't have to worry about proxy SQL or PG Bouncer or anything like that. So as part of this, what I've also done is set up a Kubernetes cluster on DigitalOcean, which I can go over and show right here. That's just got 10 nodes in it. And I'm going to go ahead and deploy this application out on that Kubernetes cluster. So we'll start off by just doing 3 of them. And we are going to, before I do that, I have to create the password so it knows how to connect. So just like anywhere else, we've got to go ahead and pass in the database URL. So I'll grab that from my environment right here, and I will go ahead and add that in. And one thing to note is that there's a bug I'll talk about. Right now, you have to pass the path to your machine's certificates. This is fixed and will be fixed in the latest Prisma release. But right now, I've got this bookmarked because my Kubernetes cluster is running a Debian derivative. I just passed this back in right there, and I've created the secret. So now that we have the secret created, and we'll go back to that Kubernetes definition right here, we've set database URL to be the URL from the database secret. We've got this container that I've built from this code, and we're going to run 3 replicas. So I'm going to go ahead and I'm going to run apply on the deployment. And as we can see with this handy dandy command line tool, that's just going to go ahead and that's going to create 3 running pods, running this exact code. I can go in right here and I can see we've got 1 container that is in state running. And I can actually go ahead and I can see that it is inserting values. So we've done the same thing I did on my personal laptop. We've gone ahead and run this service. We've just got a few more instances. And if I go back over to the console, I bet I can see that indeed we've got now 360 rows and a bunch more data inserted in here. Again, neat and fun. We've deployed a service to Kubernetes, but not super interesting. So let's take it up a notch. Instead of 3, let's run 300 and see what happens. So I'm going to go back here. I'm going to exit this, and I'm going to go ahead and I'm going to apply. And we're going to see right now, Kubernetes is going to spend some time doing a little bit of work. And I just want to take a second here and talk about, again, why this is so much fun. A lot of serverless applications, a lot of applications have a connection problem. When you're deploying things into something like Lambda, what often happens is you have so many instances running, or when you're deploying, you have twice the number of instances running for the old and the new, that you end up in a situation where your database can't accept any new connections and starts to error out. I've tested PlanetScale to take thousands or tens of thousands of connections with no problem. I've actually gotten this up to about 500 instances before, absolutely no problem. So we're going to go back into this, and now we can see we've got a whole lot more of these either in running or in creating. And Kubernetes is going to take some time to churn through this. It's not easy. But if I go into any one of these, I can go ahead and I can see again, we've got connections. It's just going no problem. In fact, it's going to warn me that I'm using too much CPU while it creates all of these, but that's fine with me. So if I go ahead and get the logs, or if I go ahead and get the list of pods, and just grab the logs from one of them, I can again see that we've got no issue here. Prisma is starting up, it's inserting. We're doing 5 connections per container, and we've got 300 containers running right now. So what's 5 times 300? That's the number of connections that we've got open to PlanetScale right now, and it's not even a problem. You can see these are all running. They're not crashing. I can get the logs of any of these, and well, some of them probably are still creating, but isn't causing an issue. We're just inserting this data over and over and over again into this database without issue. If I go back here and I look at the count of this data, I bet we've got already 31,000 rows inserted, and I bet I can even see if I can make my SQL right. Host name. Oh, doesn't like that. I'll remember how to do that later, but we would see probably around 300 unique host names because we've got 300 of these running, no problem, without issue. So we'll just go back one more time to show that off. And my CPU warning's gone. Now we've still got 300 pods with most of them running no problem. Magic. And that's the power of PlanetScale. Right there. We scaled our application. We went from 0. We went from absolutely nothing being connected from my local development environment where we got 1. And now we have this deployed in what would look like production with 300 instances of this. And if you see here, PlanetScale is not breaking a sweat. We can go ahead and it's not a problem. And that is why I always tell people PlanetScale is great. You just don't have to think about these things. No one should have to think about connection pooling. No one should have to think about configuring their connections. All I've done here is create a new client and start to query away and insert data like nothing ever happened. So now that that's done, I am going to go ahead and flip back to Keynote and just do a quick recap. So again, when we talk about PlanetScale and Prisma, we're not just talking about can they work together. We're not just talking about something that you can hack together and something that you can make work. What PlanetScale sets out to do is create one of the best, if not the best, database experiences with Prisma. We want to be able to offer Prisma configuration right in the UI so that you don't have to check about how to configure your database. We want you not to worry about connection pools and not to worry about how to deploy, but we want you to think about building your application and how can you build your application. We didn't talk today about the deployment flow because I didn't have time, but if you check out my Prisma Day talk, which is on YouTube, you can see how PlanetScale also makes it incredibly easy to do safe schema changes with just using Prisma DB push and a couple of clicks in the UI. You can have your production environment look exactly like you want with that great flow. And then The last thing that I'll talk about here before we go to Q&A is this issue number 8843. If you go back to the UI and we look at this connection string again, that issue covers needing to do the SSL cert parameter in Prisma. And in the next release of Prisma, that just won't be necessary, and it'll remove another little barrier of adoption. So my ask for everyone is go try this out. Go try out Prisma and PlanetScale together. I think in the last 60 days, we've created a great user experience from what was an already good user experience, and I'm sure there's more. I would personally love to hear from everyone who tries this out. I would personally love to hear how you're faring and how things are going, because I do believe that this is one of the easiest ways to both create, manage, and scale a database that exists right now. So yeah, I'm gonna stop sharing my screen now, and I'm gonna go over to Q&A.
Nick, that was really, really great. 300 containers, I believe probably each one of them would open up at least 2 connections to PlanetScale, and it didn't break a sweat, as you said. So that was really cool to watch. Thank you for the demo. And I thought that some of our viewers may not be familiar with Kubernetes, and so it's worth maybe sort of explaining some of the relationships between, say, Kubernetes and something like serverless, because essentially, do you want to get into that?
I would love to. So Kubernetes is a great piece of software. You know, we use it a lot internally at PlanetScale, but it's also very complex. And I use it in my demos because it's the fastest way to get a bunch of containers out there. Normally, a lot of that complexity is managed by, you know, Vercel or something like that, which can dynamically scale up and scale down the number of workers. And so when I talk about, you know, using Kubernetes and scaling out with serverless, I really mean that you just don't have to worry about the number of containers that your service is rolling out. Whether it's 1, whether it's 500, whether it's 1,000, your serverless, you know, system should be able to take care of that. I just can't necessarily make Vercel deploy 300 containers for me in the span of a demo. But you know, the thing that we want people to take away is that PlanetScale is built for serverless. PlanetScale is ready for serverless, and it doesn't matter, you know, how far out you need to scale in that regard. It'll just keep on going, no problem.
Great. Let's see if we have any questions from the audience. Yeah, we had a really nice comment from Martin, one of our community members, who it seems has been having a really, really good experience. So thank you for that, Martin. Always nice to hear from you. Alex, too, is also one of Prisma team members. He's also been using it for a side project, and he's loving it. And I think that was it in terms of the questions from the audience. There was a question that I had to you when it comes to migrations, schema migrations, and how they would sort of work with PlanetScale. Because essentially, traditionally, sort of if you were used to using Ruby on Rails or with Prisma, the idea is that you create these incremental migrations. You try to avoid as many breaking changes as possible, and then you roll those out sort of incrementally, in a way that if you're doing this together with your application code, as long as you're not introducing too many breaking changes, you can sort of, you don't need to sort of synchronize both the schema change and the code change. And so that's sort of how it's been thought of. And then PlanetScale, you came along and you introduced this idea of branching for databases. How does, what is a database branch in PlanetScale?
Yeah, that's a great question. So a database branch is just the same as any other database. It's an entire database with a copy of your up-to-date schema that you can play around with, modify, add data to. It's like a Git branch. And the idea is that just like Git branching lets you experiment with your code, you know, no developer ever sets out and goes, oh, I have to make a change. You know, how am I going to get my code set up so that I can go and make some code changes? You just create a new Git branch and you start doing whatever you want. And if it breaks, it breaks. If it doesn't break, if CI passes, you know, you're totally good. And we want databases to feel the same way. No one should ever have to dread making a database change. And I've been there at many jobs, just, you know, not even wanting to make one or knowing it's going to take me weeks. We have a blog post about this, but, you know, here at PlanetScale, we do 5 database changes a day, you know, across the entire team, just because it's so easy. And it makes making backwards compatible changes and things like that so much so much more fun because you just never have to worry about, getting a migration, through a process or anything like that. You just go branch, make your changes, and then in PlanetScale you go, let's see my diff, just like you would in a pull request, and then you click merge, and then your database gets changed. There was one thing I forgot to show off, and that's the query stats feature as well. So I would highly recommend checking out our blog post on PlanetScale, and highly recommend going and looking at that tab on your PlanetScale database, because it really is an amazing insight into what we're able to provide and kind of how your database is looking.
So coming back, so thank you for that. Maybe we can even get back to that. So essentially the process is when I create a branch on PlanetScale, it copies over the schema. It doesn't copy over the data from the main branch, right?
Yep.
So now I have this. So now I have this new branch and I'm ready to carry out some changes. So I create a new migration using, say, Prisma Migrate. And then I use the Prisma Migrate deploy after I've tested that locally and it feels good. And then the schema changes are carried out inside the inside this new branch on PlanetScale. And the changes are also recorded in this _Prisma_ migrations table. And then when I go ahead and I merge that PlanetScale database branch, essentially it carries over the schema changes from the branch onto the branch that I'm merging into.
Yep. That's exactly it. And one of the things that we experiment with is actually not even using a local database, but just using a PlanetScale database to test stuff out in. Because they're completely isolated, you can actually just create a branch and do like I did and just change your local database URL to point to that branch. And then you don't even have to worry about that step of testing locally and pushing up. You just use your PlanetScale branch like a local database instance. And when you're done, you just go in and do the equivalent of opening a pull request.
Gotcha. Nick, I'm really excited to give out the new features a go. We also had two questions from the audience who asked about pricing. And I think that's probably one of the most underrated features of PlanetScale. It's you have a very simple and understandable pricing model that also has a very generous free plan. Do you want to speak to that maybe, or even share the pricing page?
Yeah, so I would highly recommend going to planetscale.com and checking out the pricing page. That's planetscale.com/pricing. If you take a look, one of the things that we really believe in is that developers should be able to get the tools they need to kind of start their project, start their website, or start their business without having to pay a bunch of money. So PlanetScale's free tier offers 3 databases, each with 10 gigabytes of storage and 100 million rows read and 10 million rows written per month, completely free. And that is more than enough, we think, to really launch an actual website, an actual business, and scale to the point where you actually start to be needing to pay more. So more so than RDS, even more so than any other database solution, I think the big thing is we want to make it easy to get started. We want to make it easy to go from 0 to 1. And hopefully by the time your business is scaling out past this free tier, you've got some momentum, some wind behind your sales. So no credit card required, sign up, confirm your email, and then it's completely free. And it's the same set of tools and everything like that you get, from any other plan.
Wonderful. And what is coming up next for PlanetScale? What can we expect? You have quite an impressive cadence.
Yeah, that's a great question. So some of the stuff that I showed off, we've got that web console coming out soon. We're really looking at how we do some of the branch flow to make it easier to get started. So giving you an unprotected or a development database to start off with and letting you promote multiple production branches. So you can have like a production, a staging, a test and stuff like that all can be migrated into. And we're also looking at a bunch of other things. Data branching is one that we hear a lot. It's schema branching today. We'd love to be able to copy data over as part of that process. We're investigating that and really just making sure that PlanetScale remains stable, secure, solid, and then listening to our users and figuring out what they think the product is missing. So that's why I always ask people, try it out, give it a whirl. We're very responsive, and we really want to make sure that we're giving the people what they want. But that means we need to hear what the people want.
Got it. Nick, it's been a delight having you. Thank you once again for the impressive demo. I'm excited to already tweet about this. I've got a screenshot of you with the CLI tool for Kubernetes showing, I think, 300 containers.
Yep.
So yeah, thank you. And I look forward to trying this out, some of the new features, to the query console coming out, and hope to have you here soon again.
Thank you so much. Have a great rest of your day or night.
Goodbye. Okay, let's move on, and our next speaker is going to be Ryan Dsouza, and Ryan Dsouza is going to be speaking about using Prisma together with Lambda, AWS Lambda, and how to deploy Prisma on Lambda using the CDK. So you will see how this tool, the CDK, which allows you to essentially create resources in AWS, you can use that to deploy. And in case you're not familiar with Ryan, he's a developer success engineer who loves working with TypeScript and orchestrating applications on the cloud. You may have seen some of his other talks and videos on YouTube where he's showing a lot of the fun stuff happening on AWS. So now, without any further delay, I bring you Ryan D. Ryan, how's it going?
Daniel, it's going great. How about you?
Doing well. Just got back from holiday, so full of good energy, and yeah, excited for your talk.
Awesome. Yeah. And it's Prisma Meetup with the Prisma t-shirt. So yeah, it goes great.
Oh yeah, I see you're wearing the confetti shirt from the Prisma Day
Yep.
Limited Edition. Representing. Wonderful.
Yep.
Also, quick reminder to the audience. We have a raffle running. I believe that you're familiar with this book, Ryan. Designing Data-Intensive Applications by Martin Kleppmann. We're giving this away. You can go to the raffle. I will drop a link in the comments. And now that you've shared your screen, Ryan, are you ready to go?
Yep, I'm ready to go.
Okay, the stage is yours.
Awesome. So today we will be looking at deploying Prisma on Lambda. Now, Prisma can be deployed on Lambda with various tools like the Serverless framework, and you can also deploy it with native CloudFormation on AWS. But today we will be looking at using the CDK to deploy Prisma. How is it different, and what advantage does it provide? So you can see that we will be using CDK with TypeScript, and you will get full type safety for your AWS resources, as well as type safety from Prisma for your database models. Right. So I am Ryan, a developer success engineer at Prisma, and Daniel gave a great introduction. So I'll just be saying that whoever is in our Prisma Slack channel would know me as I've interacted with most of them. So good to see you on this talk. Moving on to the topics for today. So first we will see why serverless, like why would we choose serverless over traditional servers? Then we will move on to a basic introduction to Prisma. Then finally, we have a code walkthrough where we will deploy the application, like we will have our CDK resources and we will deploy it along with our Lambda function with Prisma bundle. We will also be running a load test using a tool, a CLI tool called Artillery. Now, what this does, this will run a load test against our API, and we'll see that how much time does it take for the API to respond. And the last point will be some takeaways for this talk, like what improvements can we make and what are the changes that can be done in this after deploying and after testing this. All right. So let's move on to why serverless. There are some points where we have differences between traditional servers and serverless. And the very first that comes to mind is a way to run your code without manually provisioning servers. What we used to do is that we used to have EC2 and DigitalOcean to create droplets. And we used to specify the size of the droplet. We used to specify how much, what is the RAM, what is the storage space. But in serverless, we do not need to do anything of that sort. We just upload the code that we have, and the serverless platform, in this case AWS, will launch the environment automatically. So the Lambdas will be run automatically. The environment will be provisioned. We do not need to do anything else, just run our code. So this brings us to the next point, is easier deployment. We are just shipping code and not managing servers. So it's easy to scale. If I have 1,000 invocations, if I have 10,000 invocations of requests coming in, Lambda will scale as per that. We just have to set the amount of concurrent invocations that we need, and Lambda will automatically scale based on that. We do not need to provide anything else. It is also secure by default. Now, usually when you have long-running instances, you SSH into them and then you deploy them. They can also be accessed remotely. But using Lambda, AWS provisions the environment for you and just runs your code. You cannot access that environment. You cannot SSH into that. And you cannot add or delete anything from that environment, which makes it super secure by default, rather than just having a separate instance or even deploying your server on premise. So these are the reasons that why we would choose serverless over traditional based server applications. And now let's see how Prisma comes into play. Prisma, if you don't know, is an ORM for interacting with your database. You create models in Prisma using a schema language called the Prisma schema language that will be mapped to the specific database tables that you have for your given database. In this walkthrough, we will be using Postgres as our database. The best part is you can get fields exactly as required from the database, because we have built-in type safety from Prisma. So whenever you generate the Prisma client, it generates types based on your database fields. So whatever you've defined in your model, you will get types for that. And whenever you want to fetch something, like if I want to fetch the name and the age of all the users in my database, I just have to type the name and it will automatically be added using autocomplete and IntelliSense thanks to TypeScript. Also, you can perform migrations. So Prisma Migrate is a CLI where you can perform imperative migrations, which means that if I have to make a change, if I have to add a column, then I can simply add that. And I can also add some specific changes required, because Prisma Migrate generates SQL migrations. So I can change that directly in SQL and I can get the specified output that I need. Also, Prisma has an easy to interact UI known as Prisma Studio, where I can fetch the data, where you can see the entire models and tables that you have. We will be looking at that as well in the walkthrough. Moving on to defining the schema. So now we have our user model and our post model in this case. So there are two models defined, and this will be mapped to the specific tables in the database. So it will be a user table and a post table. We have defined fields like ID, name, posts, and we have some specific attributes specific to Prisma. So this is the Prisma schema language. And we have attributes like default, unique, and updated at, which will map to the specific values in the database. So I can say that my ID is auto incrementing, so I do not need to specify that. It will be automatically added to the database. I will specify that my email is unique. So this will create a unique constraint on my email. So no two users can have the same email. There is also the name, and the name is optional because we have had a question mark here, which means that this is an optional field. And then we have some other fields. Moving on to the post model, we have the same number of fields and we have these data types mapped to the fields. So I have an int, I have a string, and I also have a Boolean. Now these will be mapped to the specific types of your database. So if you're using MySQL, Postgres, or even MongoDB, we support MongoDB now. So these will be mapped to the specific types of your database. Finally, we have something known as a relation. So in Prisma, relations are defined using the relation attribute, where we specify the model name. So a post can have an author. So the author is specified using the user model, and we specify the relation attribute, where we say that this is mapped with the author ID. So basically, if you've worked with databases, you know that we have a concept called foreign keys. So basically, here the author ID is a foreign key that references the user ID that is present in the user model. So this is how we can map our relations using Prisma. And as you can see here, that the user model has posts. And this post is an array, which means that a user can have many posts. So you can think of it as a mapping in your JavaScript or TypeScript data types where you have multiple things of the same model. So a user can have multiple posts, and the post is mapped to a specific author, which is the user in this case. So this is an example basically of a one-to-many relation. Yeah, so this was the schema. Now, moving on to the demo. Let me show you the code. And here we have the entire code. This has also been deployed to GitHub. So at the end, Daniel is going to share the link with you. Basically, this is our package.json. This is our CDK application in which we will be using Prisma. And we have some dependencies here. These are specific to AWS. So we will be deploying AWS resources. And what we will be deploying is an API. So we will be using API gateway. EC2 is for deploying a VPC. So we will be deploying an RDS database. And for that, we need a VPC. This one's interesting, AWS Lambda Node.js. This is what will help us deploy our Prisma Lambda function. And we will be seeing how that we can bundle Prisma along with our Lambda. And this uses a tool called ESBuild under the hood. ESBuild is a bundler and which performs all the necessary tree shaking and bundles our application. Then we have AWS RDS. RDS will be creating our database. So in this case, we will be using Postgres as our database. I will be showing the stack that is going to be created. Finally, we have Prisma client. And we have the Prisma CLI in dev dependencies. This is the basic setup. Let's move on to the CDK part. The CDK project is defined using a file called cdk.json, where we have all the necessary variables defined to deploy our application. So think of this as CDK's feature flags, where we specify a feature that we want. And whenever we run a command called cdk deploy, these features will be taken into consideration and our stack will be deployed accordingly. What we have here is TS node because we will be first building our application. We are writing our CDK stack in TypeScript. So we need TS node to build our application, and then it will run and deploy it. Moving on to our schema. So the schema is quite small because for the sake of this demo, I just created a sample schema. What I did was provide a data source here with the PostgreSQL as the provider and our database URL. The database URL will be similar to what we have in the example env. So I have a PostgreSQL string with the password, Postgres host, and the port, and our database name. I will be also adding a connection limit is equal to 1 as to limit the connections for our Lambda function, because it's possible that the Lambda will be reused for subsequent invocations. So the Lambda container uses the same connection. Moving on to the generator. We have a client generator in which Prisma client is our provider, which will be generating the types. Now, the main part to note here is the binary targets. What we specify here is that Prisma uses something known as a query engine. This query engine is something that Prisma uses to connect with the database and to perform all your calls and return the data specified. So this is the main part. Now, this query engine is operating system specific. So if you're running Windows, you will have a Windows query engine. If you are running Mac, you will have a Mac-based query engine. And we are running on AWS Lambda, which uses an operating system called Amazon Linux 2. And the binary target we need to specify for that is rel OpenSSL. So Prisma documentation has a list of binary targets that can be specified. And for this, we need to use rel OpenSSL. And we will see that how we bundle this binary into our final Lambda. Finally, we have the user model, and we will just create this model as of now with two fields, so the ID and the name. Now, for sake of simplicity, I have already created the models and pushed it to the database. So I've already deployed the application, but I will show you the steps to do that. And I've also seeded this database with some data. So let's look at what the seed contains. So I'll open Studio, and Studio is a nice UI, as I mentioned, that will fetch our models, and it'll fetch all the rows from our data. And here is the data in our table. We have a lot of rows here. So this is the ID and the name. I have pre-populated this. And I think we have around 100 rows. This is the data that we have, and we will be fetching this data and performing a simple load test and checking that how responsive this is on Lambda. Finally, let's move on to the stack. Now, this is the important part. Like, this is where we will be setting our Lambda function and building our Prisma into the Lambda. These are the basic imports. Like, we have all our imports for API Gateway, Node.js, EC2, RDS. The first thing we do is that we create a VPC and our RDS database. So let me quickly walk you through that. This is a simple VPC. We have created a VPC with two availability zones, so one public and one private. So we have a public and private subnet group. And then we create a security group. Now, this is what will allow RDS to be communicated over the internet. So now a Lambda will be deployed, and a Lambda needs to connect to RDS for it to function. So what we do is that we open the port 5432. This is the port for Postgres, as we use normally. And we open RDS to the world, like we say that a Lambda will be accessing this. So for this example, I've used a simple opening of a port, but in more secure cases, you will have a different setup with stricter rules. Moving on to the RDS database. This is a simple RDS database. So the best part about CDK is that you get to use TypeScript to create your entire stack. So I'm using Postgres version 12. So this is the Postgres version. And you can see here the versions supported by AWS easily. So these are all the versions supported. And we were using Postgres version 12. We will be using a small instance type of T2 micro. So this will be our RDS instance, a small one. Usually RDS instances of Postgres servers have a limited connection limit that you can have, which is why we will be using a small database in this case just for testing. The rest is the same. We will be creating our database Prisma. We will be mapping our security group. This is important because we need to specify that Lambda has access to RDS. We also make it publicly accessible at the moment so that it can be easily accessed. We can easily run our API against it. So this was our VPC and our RDS database. Let's move on to the meat of the CDK resources, that is our Lambda function. This is our Lambda function using the Node.js function class. So we have created an instance of this function. Now, what this function needs is parameters from AWS Lambda. So we've passed that we are going to use Node.js 14. This is our entry point. I will be showing you the entry point later, but this is the entry point to our function in which we will be initializing Prisma, and we will be calling the Prisma API and returning the response. This is the timeout. I used a 5-second default timeout and a memory of 512 megabytes. This should be enough for a basic application, and then you can increase it as your demands rise. Then we have the environment. The environment is what environment variables will be passed to Lambda. Now, as you must have interacted with Prisma, you know that we usually pass the database URL using an environment variable. So what we have specified in our schema is that our environment name would be db_URL. And that's the same thing we will be passing here. And this is coming from the env file that we have here. This env file is that contains our entire RDS connection string, which I will be showing you. And this is mapped to our Lambda. Then we go on to the important part of the bundling process, where we will be bundling Prisma into our Lambda function. So what we do is that we say that we have two node modules, Prisma Client and Prisma, and they are our external modules which will be used by our Lambda function. Now, this Lambda function constructor provides us with specific command hooks. Now, these are hooks that will be used while our Lambda function is being built. So think of it as performing any operation before the build is done or after the build is done, basically pre and post type of hooks. So what we are interested in is before install and after bundling. So before installation, like before we install our node modules and bundle our Lambda function, we want to copy the Prisma directory to our output where our Lambda will be bundled. So what we are doing is that we are copying this entire Prisma directory, and we are copying into the output. Now, usually CDK outputs it to a directory known as cdk.out, and this is our function which is created. So I've already deployed this, so it is easy to see. This Prisma folder will be taken from here and copied here. We need this because we will be running Prisma generate, and we'll be generating the query engine in the next step. Now let's look at the next step. The next step is going into the output directory. So we will be going into this directory specifically. We will run yarn Prisma generate. Now what Prisma generate will do is generate our query engine. The query engine will be located here. This is our query engine. So this is the query engine, and you remember that we specified something known as rel OpenSSL. This is the same query engine. So this is what is going to be used by Lambda. And this is what is generated using yarn Prisma generate. What we need to do now is Prisma generate. What it does is it defines all the engines, like the migration engine, the other engines for introspection, and stuff that we do not need to run our Lambda function. It also increases the bundle size, which is why it's not recommended to include that. And it's not necessary for our application to run. So what we do is just remove these. So what we do is perform a simple RMRF that we remove the node modules engines folder, and we also remove any specific node modules that were present. So this decreases the bundle size. Basically, what was included with the extra engines, we just have a final OpenSSL engine, the query engine, that will communicate with the database, and then we will be removing all the extra folders that we have. So this is the entire process of how to bundle the Lambda function. That part will be enclosed in this. I can show you this by running a yarn CDK synth. What CDK synth does is that it creates a specific CloudFormation template, and it creates a function. So we'll look at that later. And finally, we have our REST API. This is a simple API gateway REST API in which we pass our Lambda handler that we created above using the Lambda Node.js function. And what this handler contains is an initialization of Prisma client. So we pass Prisma client, and we say that the URL is coming from here. We just say that it's coming from the environment. And we also have a handler. Now this handler is what will be executed when we hit our API. So our API endpoint will be created, and this is what we will be hitting, and we can see the output. So what this does is that it fetches all the users. So as I showed you in Studio, we have around 100 users. So this will fetch all our users right now. And then this will send it in the body. We will look at the output of this, and this will be simply fetching 100 users and sending them as JSON. This is simply what our Lambda function will do. That is all there was to the stack. Now let's check the output of yarn CDK synth. Now this is the command. I am performing a CDK synth, and this is the profile that I'm using. So if you are familiar with the AWS CLI, we have to set a specific profile with our access and secret key so that we have permissions to deploy this step. So what we will do is that I will set a profile, and my profile is Prisma demo. What this does is this performs a CDK synth, and I'm using .env to pass the environment variables. So this will be passed to our Lambda function. And as you can see here, this is our Lambda function, which is being bundled. So our Prisma client is being installed, Prisma, and we have generated this. And as we can see here, we have performed the binary target generation. So the binary target generation will be rel OpenSSL. And this is where we generate our Prisma client. And now this is perfectly usable for AWS Lambda. We can simply deploy our stack using CDK deploy. For the sake of time, I have already deployed the stack, but you can run the same command and deploy this entire stack. I'll just show you what this looks like. So this is the AWS console. I have the RDS database here. This is already deployed. This uses Postgres, and this is the endpoint that we have. So we will be hitting this endpoint. And usually when we deploy an RDS using CDK, it generates the username and passwords using Secrets Manager. So what you need to do is go to Secrets Manager, go to this part and go to the secret and fetch the secret value from here. So this retrieve secret value will give you the username, password, port, everything, and that you can fetch and add it to your environment variable. Now let's look at CloudFormation and see if our stack is present there. I need to show you the API gateway endpoint URL. So after deploying, API gateway will generate a specific URL here. And here we have the stack. It will generate the URL in the output section. This is our API endpoint. This is what we will be performing a load test on. And let me show you a sample. So this is the API. Let me refresh it. This should give all the data. So this is all the data of our 100 users that we have. This specifies, and it's returned in the form of JSON. So this is the entire process of deploying Prisma Lambda to the CDK. Let's run a sample load test using artillery. So what I did is I prepared a short script which will load test this against our API URL. So what this does is this performs an artillery quick test. What this does is performs 50 users concurrently sending 500 requests to our Lambda. And this has started the phase, and we can see that we are getting 200, which is great. Lambda is working as expected. And we can see here the minimum time taken, the maximum time taken, and the average, which will be around 260 milliseconds. And this will perform a load test on various scenarios based on the time. And as we can see, we are getting all 200s, which is great. So our Lambda is working perfectly, and Prisma is handling the requests very well. So we are getting the requests of all 100 users concurrently very well. Let's let this run in the background for now and move on to the final part of the slides, which is the takeaways that we have from this talk. First takeaway is that only bundle the query engine for Lambda's operating system. So this is very important. You do not want to bundle your native operating system's query engine. That will increase the size of your Lambda, which is not good for deployment. Always initialize Prisma client outside the Lambda handler. So basically, this is our Lambda handler. And always initialize Prisma client outside of that, so as when we have subsequent Lambda requests, this connection can be reused, and it won't take a lot of time. It also will help decreasing the execution time. Then load test your application. So perform an artillery test, perform a test with the tool of your choice, and load test and see how much time it takes before deploying to production to check if your application is working properly or not. If your application is having issues with connections, so RDS can have some issues with connections on very high load. So you can use something like PG Bouncer if required in front of your database, and that will help a lot in connection pooling. Using a Lambda layer is quite important for faster deployments if you have multiple functions. So in our case, we just have a single function referencing Prisma. What if you have 10 functions or 15 functions? In that case, adding Prisma to each function and deploying that separately would cost a lot more. So it's better to separate Prisma into an own layer. So Lambda has a thing called layers, which helps you separate it from your actual function. So you can deploy Prisma separately as a layer, and then you can just use specific functions and reference Prisma from them. So you can deploy 15 functions, and that will be easily referenced, and it will take a lot faster to deploy. So that is another great thing. Finally, we will be introducing a data proxy for serverless in the near future. So what this will do is that it's a complete game changer. So you will not be needing the query engine anymore for your Lambda. What Prisma will do is Prisma's cloud platform will have the query engine, and you will be communicating from your Lambda to Prisma Cloud using an API. So if you have used something known as Aurora Serverless, you must be familiar with something known as the data API. What this does is uses a specific HTTP API and then queries for the data using SQL. So that is similar to what Prisma's data proxy would be. And that will take away a lot of problems away with respect to connection pooling and stuff. So this is something to watch out for in the future, and this is going to be an exciting product. Finally, there are some resources that I would like to share. First of all, the Prisma docs, which are very helpful. They will specify everything right from the query engine you need and what is the specific connection limit you need to set. This repository with code plus slides will be specified by Daniel in the YouTube live stream. And also, there is a link in this resource to an early access form. So if you are interested, you can sign up for an early access for Prisma's data proxy and try it out, which seems to be exciting. I myself am quite excited for this. And that was all from my end. And thank you very much for joining and listening to this. I hope you took something from this. And if you have any queries deploying this, or if you have any queries in specific regarding to Prisma or AWS, you can reach me on any of these platforms. I have my link specified here. And yep, I'll stop sharing my screen now. Thank you.
Ryan, thank you so much for that. That was quite an insightful talk and a really nice work through of AWS and CDK. So if I understand correctly, CDK essentially allows you as a developer to define resources basically using TypeScript code, right?
Yep, exactly. So we have TypeScript, and basically we can specify our resources as well as our application code. So that will be coupled together.
I see. Well, let's see if we have any questions from the audience. And if not, I'd like to, yeah, we didn't have any questions. We had someone who was praising you while you were giving the talk. So thank you for that. And Ryan, thank you again for the talk, and I hope to see you here soon.
Thank you for having me.
All right. Okay, we now move to the last part of today. We have a very, very special talk by Harsh Singh. And in case you're not familiar, Harsh is going to give a talk titled Database Design 101, where we'll go through the basic steps of designing a database, from defining an objective all the way to normalization. And Harsh is a 10th high school student from New York. He's interested in web development and design. He likes to participate in his school's robotics club. When he's not coding, he likes riding bicycles and playing basketball. So now I bring you Harsh. How's it going, Harsh?
It's going good. Thank you so much for having me.
Thank you for coming. I have a background noise in the thing. Can you hear that?
Oh, yep. 1 second.
All right. Okay, we lost Harsh for a moment. Perhaps he's fixing the sound in the background. Let's see if we get him back. I think many of you are quite excited to hear this talk. Talk about schema design, normalization, all of those great things. And in the meanwhile, until Harsh comes back, I probably should remind you that we have the let me just fix the brand. Yeah, we have the raffle happening. And so you can join the raffle if you haven't already. That's available at, oh, here we have you again, Harsh. So one moment, I'm just announcing the raffle. So we're going to be giving away the Designing Data Intensive Applications. You can go to priz.ly/meetup-raffle and sign up there if you want to participate. And we will announce the winner at the end. So now I bring you back, Harsh, and you've already, I see, shared your screen. Let's see if we can get the nameplates. Okay, we got the nameplates too. Okay, so Harsh, the stage is yours.
Hello, everyone. So my talk today is on database design. So without further ado, let's get right into it. So a little bit about me here. My name is Harsh Singh. I'm a high school student. I'm currently 15 years old and I'm in 10th grade. Web development is my hobby right now. I dip my feet in everything. I do front end, back end, and web design along with database stuff. Here's just my socials, my website, Twitter, GitHub, Instagram, and my email. If you ever have any questions or want to reach out to me, feel free to email me. So let's start with the founding question here first. What is a database? As per Oracle.com, a database is an organized collection of structured information or data typically stored electronically in a computer system. So in short, a database is a way to store data in a computer system. So now let's talk about what is database design. Database design is the name given to the process of designing a database. This process consists of the design, development, and the maintenance of a database. Now, here's just a look at all the things we'll be covering. We'll be looking at the different types of databases, relational databases. Then we'll be looking at how we design a database. So starting from defining an objective to organizing the information. Then we'll take a closer look at data relationships and the different types of relations in data. Then we'll be looking at how we test our design. Then we'll be taking a look at normalization. Then we'll be taking a deeper look at the different stages of normalization. And then we'll just sum it up by doing a review of what is a good database design. So let's take a look at the different types of databases. We have centralized databases, NoSQL databases, cloud, object-oriented, relational, distributed, network, and hierarchical databases. These are the 8 main types of databases which are most commonly used. But out of the 5 databases supported by Prisma, 4 are relational, and for that purpose, we'll mainly focus on relational databases today. Now, what is a relational database? As per Oracle.com, a relational database is a type of database that stores and provides access to data points that are related to one another. Now, let's move on to the actual steps of designing a database. We first start by defining an objective. The foundation of designing a database is figuring out which objective your database aims to serve. For instance, if you're a doctor, you could be designing a database to assign appropriate prescriptions to your patients. For this simple design, let's say we're a university and we're designing our database to keep track of our students, teachers, dorms, and the courses we offer, etc., etc., etc. So after we have some information, we can start to organize it into tables and columns. We need to divide our main entities into individual tables. So in our case, we can create a table for students, teachers, etc., etc., etc. Next, we need to make columns and fields within our tables. For instance, our teacher table could contain their name, their contact, email, and the courses that they teach. Next, let's take a look at data relationships. This is the part in the data design process where we look at our different tables of data and determine how they're related to one another. Based on the relationships between the tables, we can add new fields to further clarify the relationships. Now, let's take a look at relationships in data. As suggested by the name, data relations hold great importance in relational databases. They help refine table structures along with minimizing redundant data. Any association between two entities is called a relationship. There are 3 types of data relationships that exist between pairs of tables. So let's take a look at them. So first we have one-to-one relationships. As the name suggests, one-to-one relationships is when one record in a table is related to one record in another table. This relationship is rather uncommon and it's mainly used for security purposes. Generally, you'll see people, they usually do use a single column instead of a one-to-one relationship, and the main purpose of it really is granular security. So here's just an example table that we have. We have students and we have the dorm rooms. One student can only have one dorm. In case you don't know what a dorm is basically a college room like a hostel. So one student can only have one dorm. And to clarify this relationship between the 2 tables, we are using the student ID. Next, let's take a look at one-to-many and many-to-one relationships. In a one-to-many relationship, one record in a single table can be associated with multiple records in another table. This is the most common type of data relationship, and you will surely use it in a relational database. Now, let's take another look at this one-to-many relationship. So we have the students and we have books issued. One student can have multiple books issued to them. And similar to the previous example, we're clarifying the relationship using the student ID. You can see one student has 2 books issued to them. Next, let's take a look at many-to-many relationships. A many-to-many relationship works a bit differently than the other relations. A many-to-many relation occurs when multiple records in a table are related to multiple records of another table. And as said above, relational databases don't allow us to implement this relationship directly between two tables, which is why I said it works a bit differently than other relations. A workaround for this is breaking this relationship into two one-to-many relationships and adding in a third table, which is known as a join table. Now here we have our three-table example. First, we have students and their student ID. Then we have the different courses which are available and the students which are taking it, along with the teachers which are teaching it. And then we have the teachers. So we have a one-to-many relationship between the students and the courses. And as we've been using the student ID, we're using the student ID to clarify the relationship between the two tables. And the courses and the teachers also have a relationship, and we're using the teacher ID to clarify it. Now let's move on to testing our design. This is the part where we test our database design and find some potential bugs. So to do so, we can create sample data and add it into our database, experiment and play around with the example data by sending data queries and or adding in more data. This will help us find faults in our design. After this step, we'll have to adjust our database design accordingly. Now let's move on to an important part of database design, which is applying normalization rules. Simply put, normalization is the reorganization of data in a database. Normalization is a bit tricky. Since table joins are required, queries and indexing becomes more complicated, slowing down the database read speeds. Sometimes you'll even see people denormalize their databases after normalization to improve performance. Now let's look at the stages of normalization. The process of normalization can be broken down into three different stages. For this, we'll start out with an example dataset and slowly apply our normalization rules. So here's our example dataset. We have the student ID, student name, the course they're taking, the zip they're from, and the city that they're from. So we have first normal form. The first stage of normalization has two main rules. Firstly, that each cell should contain a single value, and secondly, that each entry should be unique. Now let's apply these rules into our data set. So now you can see for the students who are taking multiple courses, we have a brand new row for them. Now let's move on to second normal form. The second stage of normalization has two rules. Firstly, that the table should be in first nominal form, which it is. And secondly, that no non-prime attribute is dependent on the proper subset of any candidate key of table. So that's a bit of a complicated definition. So to simplify it, 2NF aims to make our database tables more independent, and it creates new tables for data which isn't related to the table's primary key. So as you can see, we've broken apart the table with the course names. Since course names doesn't really have anything to do with the student ID, we can partition it into a new table to make our database more independent and to avoid more bugs when we further add in data. Now let's move on to third normal form. So the third stage of normalization has two rules. Firstly, that the table should be in second normal form, and secondly, that transitive functional dependency of non-prime attributes on any superkeys should be removed. Now that's also a pretty complicated wording. So to simplify it, a transitive functional dependency is when changing one column might cause another column to change. So in this step, we need to find these dependencies and split our table again to avoid potential bugs. So as you can see, we've split apart the student zip with the student city, because when we change the zip code, we'll change the city, and the student zip code is dependent on the student city. So we've just partitioned it into another table, and that's our table in third normal form. So now let's just review it really quickly. What exactly is good database design? So before we end it, let's review how a good database design functions. A good database design is well organized, it has minimal redundancy, it works well with operators, It provides accurate data, and it ensures the reliability of data. So that's it. Database design is an essential step towards consistency within the data, efficient queries, and a high-performance application. We've covered the basics of it to get you started designing your database today. If you guys have any questions, feel free to put them in the live chat.
Thank you so much, Harsh. That was quite insightful.
My pleasure.
So you've sort of given a nice background to all the different kinds of relations that you have in relational databases. And I'm curious, what is your process when you're sort of, when you have a problem at hand and you want to model that using a database? Do you have sort of a series of steps that you go through?
Generally, I don't, because problems definitely, especially within these databases, there's a pretty wide range of problems which I face. So I don't exactly have a specific set of steps which I take. It mainly depends on problem to problem that I encounter.
Well, on that note, let's see if we have any questions. This is your moment if you have any questions. We had a lot of really, really nice comments from the crowd. Insane presentation, Harsh. So if we don't have any questions, I'd like to thank you, Harsh, for giving the talk and for giving us the walkthrough of database design.
My pleasure.
All right. Well, on that note, we now come towards the end of the meetup, and I'm excited to announce the winner of the raffle. So as we mentioned, we've got this designing data-intensive applications, and our raffle winner, let me just check the raffle system. Let's see, one moment. So we ran this with the randomizer, and the winner is Martin Adams. So Martin, will be in touch via the email that you've provided. Congratulations, I think it's a great book, and I hope that you will enjoy it. And on that note, I'd like to thank you for joining us today. Stay tuned. If you haven't already, click the subscribe button. That way you can get notified about all of the different meetups and content that we upload to YouTube, about Prisma, about databases. There's also an ongoing series that my colleague is working on building a full stack application, including authentication with Next.js and Prisma. And so if you haven't already, checked that out, and we hope to see you here again. All the best.